Oh, hello there. Have you ever wondered why doorknobs are where they are? Why is that doorknob right there and not right there? Right? What is really special about why they put doorknobs where they do? And that is kind of how we get into torque. Okay, so if I'm pressing on this door, right here is the hinges, right? The hinges are right here. This is what we call the pivot point. This is where the door rotates from, right? This would be like its axis of rotation right there. If I take my finger and I push near that axis of rotation, nothing really happens, right? So what's crazy is there's actually a whole lot of thought that went into how we actually open doors. Because if I push here, nothing really happens. I'm gonna always push with the same amount of force. If I push here, nothing really happens. Here, here. Oh, now it's starting to move. There. Hey. Right? Now the door opens. I never pushed harder. I always pushed the same. The only thing that I changed is how far away from that pivot point I was pushing. That's called the radius, right? If that right there is the pivot point, how far away we're applying a force is called the pivot point, all right? So let's break this down a little bit, and that's gonna be our introduction into torque. All right, so let's get into torque a little bit. So what is torque? Torque, just so we're clear, torque is nothing new, right? And torque it looks like that, okay? And torque is simply, it just has to do with forces. Okay, forces, and if forces that we say make something rotate, these two things combined make torque, okay? And so that's all it's doing. We've done forces before. We've done rotation before. Now the only thing is we're putting them together, and a force that makes something rotate is what we call a torque, okay? So if something's rotating, we need to have a couple different things. There's a bunch of different stuff that can rotate. There could be like a disc, right? And this disc could be spinning around. Okay, so if that's the case, there's this little middle part, that, and then it's dot, 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 down from the bottom. That middle right there is what we call the pivot point, or the axis of rotation. Okay, another really common thing, kind of like a door, we could have something like so, right? And this right here is what we would call the pivot point. And the pivot point is that one spot that your object rotates around. Okay, so in order for something to rotate, it's always going to have a pivot point. And then the other thing is, if there's a bar like this, kind of like a door, if this thing is what's rotating around, then this is what we call a lever arm. Okay, so the whole thing that's rotating is called a lever, or a lever arm. And yeah, okay, that is kind of our different types of objects that can rotate. You know, this thing could go clockwise, or it could go, actually that would be clockwise, and then this would be clockwise. The other one would be counterclockwise, right? But these things right here are called, in order to get them rotating, we have to apply a torque to it. So what is a torque? A torque is basically how you apply a force to something to make it rotate. Okay, so a torque has to do with how and where you apply a force to an object to make it rotate. Those two things are really important, the how and the where you apply the force. So let's kind of break those things down. With the little clip in the beginning about where you push on a door, right? That's where. That the reason why that doorknob is away from the pivot point is because at some point in history somebody figured out, oh, if I push further away from the pivot point, it's going to make things turn easier, right? So that means that there's a couple, important pieces. There's the radius, R. That is a important piece to this. And then there is the how you push on it. Am I pushing straight into the object? Am I pushing at a weird angle or anything like that? So the radius and the force are really important to how we make a torque. All right. And if we look at an object like this, okay, this could be a door. Right here is the pivot point. If we look at an object, where I apply a force is really important. So maybe I'm applying a force straight into the door, right? So this would be a force F. Now this distance right here, how far away it is from the pivot point, that would be, so from the pivot point, from the middle of the pivot point, all the way out to where that force is being applied, that's what we call the radius, R. Okay, so we got how far away from the pivot point you push and how you push, so like how hard is the force. The other thing that can kind of get changed up a little bit is this. Maybe you don't push directly into your object. Maybe there's some kind of weird angle with that force. Right? So there's still a force being applied, but now there's an angle going on here. And that angle we could put right here. That is the angle between my lever arm and the force. Okay? So what is important? It's not just the force. I urge you to go to a door and push on it. If you push straight into the door, right, by the door handle, the door will open, right? If you push at a weird angle and push with that same exact strength of force, that same exact push you were doing earlier, the door won't open nearly as easily. And because all we did was change the angle. And in fact, think about now if you just pushed straight into the door, right? If you just pushed straight into the door like this, right? Would that actually open the door for you? No, right? So what that means is this is totally parallel. Right here, this example is totally parallel to the door. So it's not necessarily the parallel force that makes things rotate. What it is in fact the perpendicular force, right? So this amount of force right here, bam, that force that is going perpendicularly into the lever, right? That is the force that's going to be responsible for actually making your object rotate. Okay, so this is actually what we want to call the perpendicular force. That's the one that's important. And we denote that with a big F for force, and then we put a perpendicular symbol in the subscript. So when we're looking at this for equation-wise, we just now put those things together, right? If I have a torque, and a torque has to do with where you apply a force and how you apply the force, well, the where is the radius. So I have a radius. And if I multiply that by how I apply the force, the perpendicular component of force right there, then we're good. Okay? But you will notice on the equation sheet, this gets broken down just a little bit further because this perpendicular term right here, if I want to know what this blue perpendicular arrow is, that is on the opposite side of my angle, right? So using a little trig, we could break this down even further into R. The hypotenuse was F. That's that green. We could even make it green. Right? It was F. And then we would say the sine of theta. Right? So what that does is it takes this angle and this overall force, and it finds how much of that overall force is the perpendicular part that's pushing down into our lever arm. Okay, so this right here is our equation for torque. Now what the heck do we actually set that equal to? What is the variable for torque? Well, the variable for torque is the Greek letter tau. So you basically like a weird little stunted T. So we go dip, did it. That is tau. So right there, if I'm breaking this down, let's make this skinnier since we're writing stuff. That right there is torque. Right? This right here is the radius. Right? The force is the overall force. And theta is the angle between the lever and the force. Right? So that's kind of how we break this down. If we're looking for it on the formula sheet, let's see here. There's our formula sheet, right? And this is the first page. If we scroll down to the second page, where this is going to show up is we're looking. Boom. Torque. Right? So right there. That is our equation for torque. And they actually do it a little weird. They say the radius perpendicular. I don't know why. But our equation ends up being the exact same thing. So that's it, all we're looking for. All right? So that is it. Ladies and gentlemen, the next video will be on how to actually do some of these examples.